just to give you a little bit of background to the project and what was driving it, very much in just to Daniel's point during his introduction, is it policy or is it industry driven? This is very much industry driven, and came as a result of some of the work I was doing with one of our members, Nissan, in understanding their innovation challenges around logistics. So their journey within the plant has been, they've deployed AGVs, developed their own systems and deployed them since 2007. They've now got in the region of 180 AGVs in operation. The cumulative saving to them is over 7.7 million. Their next evolution of the AGV was to look at then taking it outdoors and moving product between the various shops within the plant. So in 2018, they received some funding through Bayes and Innovate, developed their own system again, and that was driven by the fact that the systems on the market were either too expensive, or the ones that were within budget didn't meet the operational requirements of the plant. So they developed their own, and they've now deployed two. And as I say, they have an 8-ton towing capacity, moving products between the various shops within the plant. The next evolution to that was then to look at how they could automate near-side logistics. They've got a number of a high concentration of tier 1 suppliers, something in the region of 11 within 2 miles. And they wanted to look at how they might automate those HGV logistics. So earlier this year, we were successful with the partners you can see in the top right-hand corner in securing a 4.9 million 5G Create project to deliver a proof of concept and trial of a connected and automated 40-ton truck. Uniquely, we will remove the safety driver from within the cab unit, and we'll have a remote teleoperation system, which will enable a safety driver to take over control of the vehicle if it comes across any abnormal conditions. The 5G will enable discrete commands, go, no go, at particular junctions on the site. And we're seeking to have the vehicle do anonymous driving, including reversing onto a loading bay, to try and obviously replicate the vehicle movements that take place within the plant. We are quite fortunate in Nissan has their own test track, so we're going to be using their test track to validate and simulate some of the manoeuvres the truck will be doing. That's the test track you can see there. Initially, we'll start with a test vehicle, a mule, which will be a Nissan NV200 van. We'll simulate and develop the teleoperation and the autonomous system before then retrofitting it to a Terberg YT182, which is their most popular yard truck. Obviously, as part of that, we're going to be looking at a number of aspects during that test period and the test track activity. So 5G is extremely important, as you can imagine, due to the low latency required for such vehicles. And obviously, in terms of cybersecurity, even more so, given we're operating a 40-ton remote automated truck in a live manufacturing facility at Nissan. So just a little bit of detail about the routes. This is in the bottom corner there on the left. That's the Vantec, one of the Vantec warehouse units. There is a private road which has been built and runs alongside there into Nissan. There's approximately 19 vehicles doing about 100 deliveries a day when it's operating in normal conditions. And about 2 years ago, Vantec conducted a feasibility study to look at how, if they automated this route, what the savings are likely to be. And they've identified there's potentially 2 million saving just through automating this single route. So the pictures on the right just explain some of the activity we'll be doing. So the top picture replicates the interaction with the Nissan loading bay. It's quite a difficult environment that this will be in, quite wide open. So we are planning on demonstrating the teleoperation activity here and using a remote driver to take over control of that vehicle. But then when it returns on the private road down to Vantec, this bottom end here, we will then use demonstrate the vehicle's own autonomous system to be able to reverse and dock onto the Vantec site. So this really is just phase one of a much longer plan that we've got within the North East. So we're looking at how we could potentially develop a automated logistics testbed here in the North East, using this proof of concept as the catalyst for that. So we've already secured the funding through DCMS. We'll run that trial, and that will run up until March 22, when the final trials will take place. We've then identified that there are potential to look at expanding and deploying that technology across 5 other routes with 4 suppliers, all of which have private roads. So you've got the Nissan battery facility taking product in, you've got a couple of suppliers on the route, but also looking at how we might potentially take finished product, the finished vehicles off the Nissan production line and take them over to the UK compound. Further expansion will then look to how we could potentially use the unique road assets that we have in the North East. We're home to, obviously, Nissan. It's the largest manufacturing plant in the UK. The road infrastructure in and around the plant is built to handle those the shift change. So about 95% of the time it is completely underutilized. So we've got opportunities to use the public roads there. We also benefit from the fact that we've got an international advanced manufacturing park, which is a 300-acre site and deemed by the government to be a key infrastructure project for the UK. So we've got an opportunity here in the North East to look at designing industrial parks with automated logistics in mind, with synchronous supplying to Nissan, and to look at how we could then also test them on the retrofit existing road infrastructure. The opportunity, though, we see is huge. So I've talked about the near side suppliers. There are actually 11 suppliers within 2 miles of Nissan. It says 3 on the slide. It's actually 2 miles. If we were to fully automate that, just using the feasibility study we looked at originally, a 2 million saving there. If we were to automate those 11 suppliers, that is potentially a 20 to 25 million saving just for Nissan themselves. But this proof of concept has really generated an awful lot of interest. So Terberg came on board fairly recently, and when we decided we wanted to use one of their vehicles, they're really interested in the teleoperation systems that we're developing there, because they've got end users, port operators, airport operations that want to actually use teleoperation systems now. We've obviously got a lot of interest from other sectors who have similar logistic challenges. Ports and airport operations, as I mentioned, are really interested in the technologies we're developing. And in the North East, we also, the local LEP are putting forward a free port bid, but this will be a digitally enabled free port bid, and you see the activity we're doing is obviously highly synergistic with what they're trying to achieve there. And so we see a huge opportunity around the near side automated logistics side there. And ultimately, we really do want to develop the North East CAM, connected autonomous mobility activities in the region, building on some of our strengths around the manufacturing sector, but also from Newcastle University with some of the activities and trials they've been involved in as well. And there we go. That's the quick canter through what we're doing here in the North East of England.